Write the following expressions in fully factored form. So A, 12x minus 15. We have a greatest common factor here, GCF of 3, which means we can factor out a 3, and we're left with 4x minus 5. B, 2x squared plus x. Here we have a greatest common factor of x. So we factor out an x, and we are left with 2x plus 1. C, x squared minus 16. This is a difference of square or squares. So we can factor this as we're going to end up with two binomials, and we would take the square root of the first term, which is just x, square root of the second term, which is 4, and then we put a plus and a minus. In D, we have 25 minus 4a squared. Again, this is a difference of squares. Square root of 25 is 5. Square root of 4a squared is 2a. And then we put a plus and a minus. We have in E, we have x cubed plus 9x. Here we have a GCF. The GCF is x, which leaves us with x squared plus 9. This is not a difference of squares because we do not have a minus sign between the two perfect squares. So this is it. We're done here. In F, we have x cubed minus 9x. We have a GCF of x here, which leaves us with x squared minus 9. X squared minus 9 is a difference of squares. So we have to continue factoring here. The GCF x just stays where it is. And then we factor the binomial x squared minus 9 as a difference of squares, which leaves us with x plus 3 times x minus 3. In G, we have 16x minus 4x squared. We have a GCF here of 4x. And then we're left with 4 minus x. This is not a difference of squares because this term here is not a perfect square. So we're done factoring here. And then finally, h, we have 16x minus 4x cubed. We have a GCF, that's x. And then we're left with 16 minus 4x squared. This is a difference of squares. So we continue to factor this as a difference of squares. We're going to get 4 minus 2x and 4 plus 2x.